Hello and welcome to Half-Life Calculations. You have probably discussed Half-Life at some other level before. So we're just going to start with kind of a little example here where if we pretended that we could really count some carbon atoms, and we started with 32 of them. Each time we went through a half-life, we would lose half of those carbons. So I'd expect to have 16 carbons here. If I chop those in half again, I'd then have 8 remaining. Oops, I forgot a half-life there. So at this half-life right here, I'd have 8 carbons. Then I get down to 1, 2, 3, 4 carbons. Finally, I would have 2 carbons left after cutting those in half, and then at the end, or at the last bit of my graph, I would have 1 carbon left. This is a little bit of a deceiving example because it's kind of a simplification. So if we started with 32 carbon atoms, which is not really very many, it'd really be like 32 times 10 to the 23rd or something. After one half-life, again, we would be down to 16, which is 50% of our original carbons. It's also nice to look at fractions with this. I don't usually say it's nice to look at fractions, but this time it is. So that's half of what we started with, hence the name half-life. After 2 half-lives, we would then be down to 8 remaining carbons from our initial, which is 25 of our initial carbons, or 1/4. After 3 half-lives, we go down to 4, which is 12.5%, or 1/8. After 4 half-lives, we then go down to 2. This is 6.25 of our original carbons, or 1/16. After 5, 1 remain, and this is 3.125 of our initial carbons, or 1/32. Now, what's important to keep in mind is, if we continue to go from here, we don't go from 1 down to 0, we would then go to half a carbon. This is an exponential decay, so it never actually reaches 0. So what actually happens during half-life is you have something decaying and turning into something else. When we talk about the example of carbon-14, it turns into nitrogen, which is then a gas, so the nitrogen just leaves. We will talk a little bit more about decay series. We'll do a uranium decay series, so you'll get to see a little bit more what this looks like. So some half-life calculation problems that you might have to do. Radon-222 is a carcinogenic house pollutant. If your basement was found to contain 20 grams of radon-222, how many grams would remain after about 19 days? This is actually something pretty commonly found in the basements around here, and you can actually have it mitigated in your home with a little vent. So the first thing that we're going to do in this problem is we're going to find radon-222 on reference table N. So as you're flipping to reference table N, please be careful in the difference between radon and radium, Rn and Ra. Be very confident that you're using the right one. So this is 3.823 days. We're going to determine how many half-lives will occur. In order to do that, we're going to take our total time, and we're going to divide that by how long the half-life is. So our total time is 19 days divided by 3.823 days, which gives us 4.96 half-lives. Now, you can actually have fractional or decimal half-lives. We are not going to really deal with those in Regents chemistry, so we're going to say, okay, this is pretty darn close to 5 half-lives. So now we're going to draw something I call an arrow diagram. So we have to look back at our starting amount. We initially had 20 grams. And let's see how many half-lives are going to pass here. So if we had 20 grams to start with, 1 half-life gets us down to 10 grams. 2 half-lives gets us down to 5 grams. 3 half-lives gets us down to 2.5 grams. 4 half-lives gets us down to 1.25 grams. And 5 half-lives gets us down to our answer, which is 0.75 grams of radon remaining. If we were to have 400 grams, of P32 decay down to 50 grams, and we wanted to know how long that would take. First thing we're always going to do is find what's in question here, phosphorus 32 on table phosphorus 42 has a half-life, or phosphorus 32, sorry, has a half-life of 14.82 days. A little bit of a different approach to this question. We're actually given starting and ending amounts, so we need to figure out how many half-lives went by. So if we started with 400 grams and we decayed that once, we would have 200 grams. We decayed that twice, we get down to 100 grams. If we decayed that a third time, we ended up at our 50 grams. So what we want to look at is how many times did we decay? 1, 2, 3. So 3 half-lives went by. So I say, okay, I've got 3 half-lives times the length of my half-life, which is my 14.28 days. And 3 times 14.28 gives us 42.84 days. Almost 43 days. Finally, what percent of K42 in a sample will remain after 49.6 hours? So we look up potassium 42 first. Potassium 42, and you have to be careful, there's 2 potassiums on here. It has a half-life of 12.36 hours. And we're wondering how much of this is going to remain after this many hours have gone by. So we're going to need to determine how many half-lives passed. So we're going to do, again, total time over half-life length. So that's going to be 49.6 hours divided by 12.36 hours. Gives us 4 half-lives. So we know 4 half-lives are going by. This time we're going to do this with percent. So they didn't tell us how much K42 we're starting out with. So we can make an assumption that we have 100% of our sample to start with. And we need to decay this 4 times. So decay number 1 gets us down to 50%. Decay number 2 down to 25%. Decay number 3 gets us down to 12.5%. Decay number 4, which is our last decay, will get us down to 6.25%. So we will be practicing these in class tomorrow and wrapping up half-life calculations together.